So guys, before even we start solving the problem, let's see how we can do a pre-order traversal. So here's a tree which was given in an example where the root node is 8 and it's a binary search tree. So given that part, let's start to form a pseudocode. And how to do that? Let's write a function. It's a pseudocode. So traverse, yeah. So it's a traverse, it's a function. What to do? You actually print the root node first, right? You then again recursively, so it's a recursive function, root dot left, and then you do a traverse root dot right. So this is how you traverse. So following this part, let's build the array of the pre-order traversal from this tree and following this program. First root node is 8, right? Then it would go on to the left, which is 5 here, and as it's going to 5, the 5 would, so let's say this is called with 5 now, and this would be called again the traverse, so it will be printing the root, right? And then it will again go into the left because it's a recursive call, so we'll get 1. So now as it goes to 1, we won't find any other road next to 1 because it's all null, it's a leaf node, right? It goes back to 5 and then print 7, right? And then so now it comes down to again 5 and then come back to again 8, and now we have exhausted all the left subtree. So now it goes back to again 8, and in this part of the subtree it prints 10, then you have nothing on the left, so it prints 12, right? So that's how you build a pre-order traversal from a binary search tree. Now, as we have already seen how we can solve the pre-order traversal given a binary search tree, so we have some idea what pre-order traversal looks like and when put in an array, right? So the problem we can see is right now is that the first element of this pre-order traversal would definitely be root, right? So 8 is going to be the root. So let's try and form the tree. 8 is going to be the root. What next? Like 5 is less than 8. Maybe it's left here. 1. Why? Because it's already left. We are going in left direction. And then comes 7, right? But 7 is greater than 1 and 5. But it's also less than 8, probably here. So this kind of in a situation where we are not confirmed how we are going to fixate, like is it a left element or a right element, we have to find an algorithm that works in all conditions. So the algorithm would look like somewhere, if you can observe in this array, that we have 8 as the root. Now every other element this is less than 8, right? And then comes 10. So 10 is a number which is next to 8, like in the increasing order. So if you can see, like in our tree as well, the 10 comes on the right of 8, right? So now we know that there's a kind of a pattern emerging out of this array. So if we have a root node as 8, we know that 10 could be on the right, because it's greater than that, and everything that occurs less than 8, right, it occurs on the left part. So we can have 5, right? We can have 1 and we can have 7. So this is a left subtree. So 5 and 7 will be the part of the left subtree, right? This will be the left subtree, and anything that occurs beyond 8 or after 8 will be part of the right subtree. So now we have placed. Now the question is, how do we place 7? So if you can see, we did it for 8, right? So if we keep on looping over all the indices of this array, so let's say we are on 5. So on 5, we'll see what all is less than 5, right? 1 is less than 5, but 7 is going to be greater than 5. So that's the first immediate next number to 5. We'll have it here. Again, we go on to 1. There's nothing less than that. Everything is greater than that. We'll come back, and same for like 7. When we are at 7, right? So we've already visited the nodes, right? And then when we are exhausted on the left subtree, we come on to the right subtree, which starts with 10. With 10, we know that the next number that is going to be, and 10 is greater than 8, so we have already placed that on the right side of 8. And now 12, it is greater than 10, so we're going to place it on the right side because there is no left side here. So that's how we can complete our tree here. So we can form this as an algorithm where if you see that we have some ranges, right? So whatever occurs on the left subtree is between the range which is like less than 8, and this is like which is greater than 8. So if this is less than 8, what we can do is we can have a range. So min max range could be for left subtree 8 comma anything, let's say minus infinity to start with. This is just to kickstart that. And similarly here, min and max range, so min is 8 and max could be infinity, right? We do this for each and every node. Right now we are just referencing it for the node 8, and we have to do it for every node. And with that thing in mind, what we need to be careful of is that we need to have a global index. So we have to maintain a index because this is a recursion, so it's going to be a global index which would be keeping track of the indices we are currently at, or the node we are currently at in the array. So let's start with the algorithm to put into place. It's 8, right? So here it is like minus infinity to 8, although in the left subtree, and 8 to infinity, right? So when we are at 8, what we can do is we're going to call a let's say traverse function again, or maybe I can put it as just t with your traverse function, and I'll be calling it like minus inf with the min max ranges. That's it, right? And also in this case, as soon as I call any of the left and right, before that I'll be incrementing the index. So now I'm at index 5, right? So now I'm going to be at index 5. I'm just writing it here, and then this will be like t8 comma inf, right? So let's say I call t minus 8 comma inf again, and this, so I have an index of 5. It goes and it creates a node 5, right? Because it is less than 8 and satisfy my condition. I can go on, and now I can call t minus f comma, so what will be my lower, because 8 was my upper value minus nf, but now if I go on to next, 5 is my current node now, so my upper value reduces to just 5 here, and my higher value reduces to what, t, it could be just because this is my current node till 8. So that's how we are doing, right? Because we are keeping in the right, so it's just the value that we are at the current node, and because these are the recursive functions, so we're going to retain the min max from the previous calls. Here we retain 8 in that, and then as we go, and now the index has moved to 1. If you can see it, so the index has moved to 1. What I'll do is, again, I'll have a call. So this is, I'll create a node 1. I'll call minus inf comma 1, and I'll call t 1 comma 5, right? So there's nothing here because this should be returning null, right? So this is all null, and this is a leaf node. So this is going to be leaf node. I mean, it is like 5 comma 8. Obviously what I'm going to do is it's going to be so this was a 1, so now the index, as soon as it called after 1, like this iteration, so this will be 7 here, right? So index moved to 7, and now what I'll do is, like, so in this node, if I can write it here, the index has moved to 7 in the array, as you can see on the top. So now what I'll do is I'll first create the node 7, and I'll call t, so my lower value, my which was retained 5, and the value itself, and t 7 comma 8, which I retained from the previous parent node. So that's all. And now there's nothing there to be found because there's no such node between 5 and 7, no such node between 7 and 8. We have null, and we go on. So now this is the recursion, so this would just hop back to 5 because we've already fulfilled 7, 5, it will go to 8, and it go into the right node. With the right node, we'll again call helper t8, and then we'll create the 10th node, because so now it will call and go on to the right part of the subtree, and then what we'll have is, like, we'll have the 10th node, because when we were here the index was incremented to 10, right? And now we are at the 10th node. So in the 10th node, what we'll call is, like, again t of 8 comma 10, and here we'll call t of 10 comma infinity. So here nothing new, null, but now we are here, so the node has been incremented to 12, so t minus 8. So now this is again null, and this one, because it has been incremented to 12, we'll call the 12 part again. So we'll create 12 node, and then again the same thing happens, and we'll call t, and we'll finally see that there's no node and it returns null, and 12 is the right node or the leaf node, and then a child to 10. So that's how we can actually create algorithm around that and see how it recursively solves a problem while we have a global index that we are keeping on to loop over the array indices by indices. Now let's jump onto the code. Alright guys, so let's start the code. To create that, first, as it's going to be a recursive solution, we create a recursive function, right? So, and we'll return that here. So let's create the first recursive function, traverse recursively, yeah, that's it. And as we have seen in the iPad description and the solution that we were doing there, we need a min and a max value. So to have a minimum as a negative infinity, we can have min underscore value, and for the max, similarly, we can have integer dot max value, comma. So what we are going to do is, like, we're going to actually again, like, send pre-order traversal here. Maybe I'll just do this, and okay, so sorry, so pre-order traversal here, and that's it. So I'm sending the array along with that. Next time, what I'm going to do is, like, I'm going to define a function which is going to be again public function. So next I'm going to be defining a function, the recursive one, that supposed to return the traverse recursive part. There you go. And then define int min, int max, and int array as pre-order, right? We're going to send it across all the time, and we already like have index 0 here, so it's a global index variable to keep a track of all the indices that we're going to store and that we're going to move on. So starting with that, so first what we can do is, like, have the template. So there has to be condition to stop recursion, right? So stop recursion, and then what I'm going to do is and have a range check for value of the node if it lies between min and max, right? So that's what I'm going to do. And then finally, so what I'm going to do is, if this range check succeeds, I'm going to actually go recursively in left node, right? And then in, so this is what I'm trying to create, the left and the right part. So, and then return the node finally. Okay, so that's what's gonna happen. So to start with, I can, okay, so initially, so if my, if my index equals to preorder.length, so I return null. So this will be a return as null node. So that's as simple as that. Then I'm going to have my value inside the preorder. So this is a value. So it's a temporary variable for the value of the at that particular index that we are at in the preorder array. So it's index, right? And then pre node, I can have a node equals to null. I'm just initializing it as null. And now, so condition, this has already been done, and I'm going to do a range check if my value is greater than min and my value is greater than less than max, right? So that's what I'm going to do, just greater than min, simple check. And then in the if condition, what I'm going to do, I'm going to assign the value of the node as the tree node. I'm creating a new node here with the val, and then I'm going to also increment the index so that I move on to, as we've seen in the recursive solution, like we have to increment the index, like every time we go on, before just we go on to inside the recursion calls of node left and node right. So left equals to, that's what I'm going to establish. So traverse recursively. What I'm going to do, I'm going to have, this is the left subtree call, so min and the val and the pre-order array obviously, and similarly what I'm going to copy that. Okay, so I'm going to copy that to, so this will be, so the maximum will be the val, so min will be a val and this will be the max, right? So the right subtree and the left subtree that we are going to establish for each and every node. Okay, so there you go with the right part. And now finally, once we are through with all the conditions, right, I think a job is done here. We're going to return the node and I think this should work. We are not doing anything fancy here. Pre-order index, we have everything in control. Let's try and run this code. It works. Let's try and submit this code. It worked. Yeah. If you really like the videos, guys, do like, do comment, and do subscribe to my channel for more such videos. Thank you for watching.